Nuclear energy, a carbon-free energy source harnessing the immense power of the atom. Nuclear is one of the most effective energy sources available. It's clean, stable, and efficient. So how did nuclear come to be? What are the distinctive traits about it? And why is it a necessary ingredient for addressing climate change? The nuclear chain reaction was discovered by James Chadwick, a British physicist, in 1932, ushering in the nuclear age. A decade later, Chicago Pile 1, a reactor and literal pile of graphite lead blocks, achieves criticality at the University of Chicago. And, only 1 year later, fueled by the effort of World War II, reactors at Hanford in the United States begin producing weapons-grade plutonium. In 1957, amid concerns of misuse of nuclear weapons, and with prospects of clean energy for all, the International Atomic Energy Agency, or IAEA, is founded by the United Nations. Later, the agency would create the International Nuclear and Radiological Event Scale, or INES, a scale from 1 to 7, an anomaly to a major accident. In the 1950s and 60s, Generation 2 nuclear reactors are being designed and manufactured. They have various designs and properties, but most of all, these are no longer considered experimental reactors and enter the commercial energy industry. And, in the late 1990s, Generation 3 reactors enter the scene. The hallmark of these new reactors are their safety, including both active and passive systems, and an emphasis on simplicity and efficiency of design. Getting here, however, required some costly accidents that continue to have an effect on the perception of nuclear energy today. In late December of 1961, a U.S. military experiment, the Stationary Low Power Reactor No. 1, or SL-1, was being placed into maintenance mode when the reactor engineer accidentally removed the central control rod too far, causing a prompt criticality accident. For 4 milliseconds, the reactor produced nearly 20 gigawatts of power when it was rated for 3 megawatts, and the entire reactor vessel jumped nearly 10 feet into the air. 3 reactor engineers were killed, but no significant radiation escaped the building. This is still the deadliest nuclear accident in American history. It received an INES rating of 4, accident with local consequences. Then, in March 1979, at 3 Mile Island, a stuck valve and mishandling of regulation causes a loss of coolant accident. This results in a partial nuclear meltdown and radioactive coolant being released in the reactor building. The accident is mostly contained, and while some radiation is vented into the atmosphere, it's found to have no significant effect on the surrounding area. On the INES scale, this rated at a 5, an accident with wider consequences. In the meantime, 3 Mile Island's second reactor has continued operation till today, when the plant is to be shut down for economic reasons. April 1986, Ukraine, then the Soviet Union. Chernobyl's Reactor 4 is to undergo a test to determine if in the worst case the turbine can keep rotating long enough to power the coolant system till the generators come online. From the start, nothing goes right. The inexperienced night crew is expected to perform the test. The emergency core cooling system is shut off for the test as routine. 193 out of 211 control rods are manually removed to maintain power levels. A dozen alarms are ignored, the reactor is in a highly unstable state, and finally a scram is triggered, inserting all the control rods, which have a crucial design flaw causing a power surge. A complete meltdown and multiple explosions occur. Chernobyl is one of 2 Level 7 events. In March 2011, at the Fukushima Daiichi nuclear power plant, a magnitude 9.0 earthquake occurs, causing its 3 active reactors to scram. Then, about 1 hour later, a 14-meter tsunami strikes the facility, flooding the plant. In 2006, 3 backup generators had been constructed up the hill. These continued functioning throughout the disaster, but their switching stations were still located down the hill in an exposed building and were knocked out by the tsunami. For the better part of a decade, the plant had been warned about its risk of tsunami and its vulnerability to earthquake for 2 decades. This accident resulted in 3 nuclear meltdowns, and is the second Level 7 event, though no fatalities have occurred as a result, and radiological emissions were 10% of Chernobyl. Today, hard lessons have been taken from these accidents. Design has evolved, and technology continues its forward advance. Nuclear is a strong, mature, and viable energy source, and it is a global energy source, producing 20% of power in the United States and 11% globally. In the United States, that's 713 billion kilowatt-hours, more than every renewable energy source combined. Some countries even have higher shares of nuclear energy. France's power grid consists of 72.3% nuclear. Further, nuclear is one of the most stable energy sources available. It has an average operational capacity of 90%. Compared to other renewables, nuclear is a steadfast source of power, being more resilient to environmental and societal effects than other power sources, and nuclear is able to produce more power for its size than other sources. An equivalent wind farm to a gigawatt reactor requires about 235 square miles. That's larger than Chicago. And in terms of resilience, after the Chernobyl disaster, the other 3 reactors at the plant continued operation unimpeded until December 2000. Nuclear reactors are highly efficient, needing relatively small amounts of fuel to continue operation for longer periods of time. Unlike coal or oil, which requires a constant stream of fuel every day, nuclear can maintain operation with vastly fewer fuel deliveries. Nuclear energy does have a significant drawback. It's expensive and time-consuming to build reactors, and decommissioning old plants takes time. Quick change is not something gigawatt reactors handle well, similar to other power sources such as hydro. But there is a place for smaller reactors, specifically a new breed of reactors called small modular reactors. These reactors are easier to manufacture, safer, and can be transported virtually anywhere. Whether they are commercially viable, however, is yet to be seen. The versatility of nuclear reactors has also earned them a place all over the planet. They can come in many shapes and sizes, ranging from producing kilowatts of power to gigawatts. They've been used in the Arctic to power bases, in urban settings to power cities, and in space to power satellites and stations. Their sizes also vary from 1 or 2 meters to needing an entire building. Other characteristics are considered too. Certain reactors are designed for longevity and can go without refueling for 3 decades at a time. Most importantly, nuclear reactors, including accidents, have relatively little impact on human health, the environment, and the economy compared to other power sources. Studies from independent journals and from major governmental organizations have ranked the impacts of nuclear lower than all energy sources except hydro and wind. Even solar had more impact than nuclear. These estimates include the long-term impacts of nuclear disasters, even out to multiple centuries. Further, hydroelectric has caused more fatalities with singular failures than nuclear entirely has. In terms of environmental impacts alone, nuclear has the least direct and indirect impacts of any power source except possibly hydro, producing the least carbon emissions per kilowatt hour. Nuclear is considered a critical part of the Paris Climate Agreement, and as part of the agreement, the International Energy Agency has called for the nuclear capacity of the planet to nearly double in order to meet the agreement's goal of 2 degrees or less of global temperature increase. However, there are troubling signs in the US and abroad. The price of natural gas for power production has fallen so low that it threatens the nuclear industry with bankruptcy. Almost 50% of the US nuclear industry is threatening to close, and this would be an astronomical hit to carbon emissions, as these plants will likely be replaced with natural gas power plants. These nuclear plants are petitioning their states to stay open, and already some are saying, "What's the point?" Nuclear energy. Potent. Green. Safe. An energy source with bad public image. A technological marvel. And a necessary ingredient for addressing climate change. Thanks for watching. Until next time.